Now, Stephanie, my former roommate, she's a lot of fun to live with. She's got a bachelor's from MIT in biology with a minor in food and nutrition, PhD in electrical engineering, and she's been studying many different areas in her research, including human auditory modeling, spoken dialogue systems, natural language processing, information retrieval, summarization, and computational biology. I don't even know what that means. Published nearly 200 articles in technical journals that were refereed, and written several essays. She's developed spoken dialogue systems to support intelligent search and summarization of user-provided reviews in the medical domain. However, her main passion is biology and healing and sulfur, and she strongly advocates a high carbohydrate diet and is looking at also, pardon me, no, this says high, which is it? Okay, well, there's a typo here. Sorry. She could tell you better than I can. Here's Stephanie. But a lot of biological research.
Thank you very much. It's great to be here. Can we get lights off so that this will do better? Maybe the front lights? Ah, good. Is that all right? Yeah. All right, great. Here comes the sun. That's a topic of mine. I'm happy to be here in California. I love sunny California, lots of sun. And weather cooperated with me last week. I got lots of chances to renew my sun exposure. And this has got a bit turned on here before it's going to work. There we go. So the only reason to worry about inadequate sun exposure is the possibility of a vitamin D deficiency, right? So just take a vitamin D supplement and you'll be all set. No? Good. Wrong. All right. A radical theory. Our bodies need sun exposure to produce cholesterol sulfate, which provides cholesterol, sulfate, negative charge, and energy to all the tissues of the body. That's my basic hypothesis that I've been promoting for the last few years. So here's an outline of what my talk will be about. First, talking about the fact that people who live in sunny places are healthier. Then I will discuss both cholesterol and sulfate independently, and the molecule cholesterol sulfate as well, and their importance to our health. I'm going to talk about impaired cholesterol transport, which I think is the key problem underlying heart disease. It's not cholesterol deficiency, it's impaired cholesterol transport, and I think it's due to sulfate deficiency. I'm going to talk about autism. I've been really studying autism, and I have several papers on it that have been published, some of them very recently, actually just the last couple of weeks. So I've got papers on Alzheimer's, metabolic syndrome, and then a lot of papers on autism in the medical literature. Are sunscreens doing more bad than good? And then what to do if you live in a rainy place. So that's the agenda. Okay, this is my first topic. Interesting graph here from 1996, heart disease and mortality in sunlight. This is showing the hours of sunshine per year in different places. Each dot is a place, and it's the statistics. Death rate from heart disease over here, high death rate over this end with few hours of sunlight, and low death rate from heart disease with more hours of sunlight. So it's a pretty good linear relationship. Lack of sunlight may raise stroke risk. This is another paper. Strokes are caused by blood instability, clots, and hemorrhages. I believe those are due directly to insufficient sulfate in the blood. This study involved a lot of people, and they tracked the history of where they had lived in the past and looked at the weather statistics for those places, and they found a 60% increased risk to stroke for places who lived in either low sun or high latitude. Here's another paper, the Scots paradox. The mortality of the Scots is higher than that of the British across all social classes, even though many aspects of the culture, the environment, and the health provisions are the same. So the difference is that the Scotland has poorer climate, less sun, and colder. And so these diseases are in fact associated with insufficient vitamin D and sunshine. Here's a tale of two cities. This is a paper that talks about sun exposure, and Belfast, Ireland, and Toulouse, France, when you look at them and you count their cardiovascular rate, so their death from either cardiovascular disease, that's the blue, or anything else is the red. And you can see tremendous difference in the cardiovascular death between these two places. This was for men in their 50s. It was a range of men sort of in this early range of 50 to 65 mortality for heart disease. So it's clearly a huge difference related to the fact that Toulouse has sun, and I think that's a key difference. Here's a paper about Sweden, ultraviolet exposure and mortality among women in Sweden. 38,000 women were studied, aged 30 to 49. They were monitored for a long time, 15 years, and then they asked them a questionnaire about their frequency of sunbathing, vacations, and also their sunburn in their childhood. And so they were looking at their previous sunburn. Increased sunburn frequency was associated with reduced all-cause mortality, which is really surprising. It's not that the sunburn was good for them, but the sunburn indicated that they were getting more sun. And people who took the sunbathing vacations more than once a year reduced their risk to cardiovascular disease and mortality. So vitamin D, I already said this is not the answer. Here's some proof, or at least some good evidence. This was a study that was published just recently, 2012, 150 people. A lot of people are doing studies right now on vitamin D because they see that people who have high serum vitamin D levels have reduced heart disease risk. They see that sunny places have reduced risk. They think it must be that the vitamin D is doing that, but I think it's a proxy. The vitamin D is an indicator of the amount of sun exposures you've gotten. And it's not really the reason why you're getting the protection for your immune system, your cardiovascular health, diabetes, Alzheimer's, all of these things. People think they're associated with vitamin D, but I think it's the sun. This study, so these people had both heart disease risk profile in their parameters, and they had vitamin D deficiency, so they're perfect people for giving vitamin D2. They gave them these 50,000 units over a period of 8 weeks, and then they measured all these parameters, which are, all of these results are negative. They're going in the wrong direction in terms of protecting from heart disease. And increased serum LDL levels is not what you're looking for. That's the bad guy in the HDL LDL profile. So I don't think vitamin D3 supplements are the answer. Here's a chart of skin melanoma over a period of time from 1974 to 2006. Melanoma is, of course, the very dangerous skin cancer that can kill you. And as you can see, there has been a very steady linear rise in the rate over this time period, the same time period during which we increased our use of sunscreen 30-fold. So there's something wrong with this picture. We're using sunscreen to protect us from skin cancer, and what we're getting is more skin cancer. So here's a little bit of a lesson about vitamin D. Here's cholesterol, chemical formula, chemical structure. Here's vitamin D, almost the same thing. You shine the sun, you produce vitamin D from cholesterol. And a lot of people don't realize that, but vitamin D is very, very close to cholesterol in its formula structure. And this is the difference, just that this ring is broken right here. It's a very, very minimal change to the molecule. And then, so it's synthesized in the skin from cholesterol upon sun exposure. But both cholesterol and vitamin D are sulfated upon sun exposure. So here's cholesterol, and this is cholesterol sulfate. That's the sulfate, SO4. And that's what makes all the difference. So, why is it different? The important thing is that by having this anionic unit stuck onto the molecule, it makes the molecule both water-soluble and fat-soluble. And this is a very important point. And the reason is that now you can transport it across water-based domains, and it won't get stuck. So this is, I think, a huge problem today. So how to stay healthy? Plenty of dietary sulfur. You need that for the sulfate. Plenty of dietary cholesterol, because cholesterol is really good for you, and you'll get to that in a moment. Plenty of sun exposure. So this is my next topic, the importance of cholesterol and sulfate to health. Think about sulfate. And sulfate is a very, very underappreciated molecule. So we know this, vitamin D sulfate, cholesterol sulfate, and I think the cholesterol sulfate is the more important molecule. So, and then many of the alleged benefits of vitamin D, and I've already said this, cancer, diabetes, cardiovascular disease, immune system, I think those are benefits of cholesterol sulfate. So here's my proposal. You should know it by now. Cholesterol sulfate, produced in the skin, supplies sulfate cholesterol energy and negative charge to all the tissues, synthesized from sulfite in the skin and bloodstream, utilizing the energy from sunlight as a catalyst. And this protects from the UV damage, and it keeps the microbes out. And then sunscreen interferes directly with this process. It doesn't just block the sun, but it interferes with the process of producing the cholesterol sulfate. So the skin is, I like to think of the skin as a solar-powered battery for the body. All right, so there's actually not enough written about cholesterol sulfate. It's a sleeper. People don't realize the importance of it. This is a great article. It's a review article by this guy Straught, and it really kind of says everything that was known at that time in 2003. It's still the first thing you'll find if you search for this molecule on the web. Synthesized in great abundance in the skin, present always in the blood serum, but in small amounts. And it collects in the membranes, the red blood cells, and gives them a negative charge field around them. And this turns out to be really, really important for keeping them from sticking together. So this is going to prevent you from things like blood clots. Both the platelets and the red blood cells have cholesterol sulfate in their membrane that gives them the negative charge and makes them repel each other so that they won't glom up and make the thrombosis. It also protects the red blood cells from falling apart. So it can travel, as I said, freely in the blood and readily migrates. It very easily hops in from one membrane to the next. So it's extremely mobile. And it's very transient in the blood. It comes and then it goes. So this is important because it's so agile. Now I'm going to talk about cholesterol. People have demonized cholesterol, and I think it's a huge problem in today's society. And I think that a key problem in today's society is cholesterol deficiency. That many, many people are suffering from cholesterol deficiency in their brain and all the cell membranes of their body. Plants don't contain any cholesterol. So you can only get it from animal foods in your diet. Of course, we can synthesize it in our body. But the cholesterol is what gives animals two important things: mobility and a nervous system, the brain and the nervous system. These are things plants don't have. And you need cholesterol in order to make those things work. So I think cholesterol is to animals as chlorophyll is to plants. Cholesterol is a miracle worker. Here's some of the things it does. It's very essential in the synapse and between two neurons to communicate the signal. It insulates the myelin sheath to protect it from loss, leakage of the signal traveling through the axon. It prevents ion leaks in the cells, and that is extremely important. Keeps the membrane, keeps the potassium from leaking out and keeps the sodium from leaking in, and it protects from pathogens. It's also in LDL and HDL, and it's essential for protecting their contents from oxidation damage and from pathogens during transport. And then it's a precursor not just to vitamin D, but to all these other sex hormones as well as cortisol. It also aids in the digestion of fats. Sulfate, I think, is vastly unappreciated. It's the fourth most abundant anion in the blood, and as I've said, it protects from coagulation. It's also very important for detoxifying all these things, the drugs, things like aluminum and mercury, food additives, all these things that we're exposed to in today's society. It inactivates neurotransmitters, and it's an essential component of the extracellular matrix proteins. We were talking about the extracellular matrix earlier, and there's a lot of sulfate in there. And that sulfate is very, very important for making it healthy. There's something in the brain called cerebroside sulfate, which is a major constituent of the myelin sheath surrounding the axons. So the brain is not going to be happy without sulfate either. This is a picture of sulfated glycosaminoglycans. These things are kind of cool. They're sugar molecules. These are sugars. And then they've got all these sulfates stuck on them. See, they've got the sulfates attached everywhere. And the sulfates are very, very important to the function of these things which are in this extracellular matrix. So there's prominent in this matrix in all cells, and the sulfate can become deficient, and that can lead to diseases like digestive problems. And it plays an essential role in cell metabolism, so very important to the cell. So these are also called mucopolysaccharides, if you've heard that term. And I propose that cholesterol sulfate is a major supplier of the sulfate to these gags. So here's a list of the various things that these things do. It's quite impressive. Stimulating cell metabolism, fatty acid metabolism, RNA and DNA, increasing the growth of normal cells, anti-atherosclerosis, anti-inflammatory, anti-thrombogenic, and coagulant. And then it improves your circulation, helps in healing. I mean, it's an amazing amount of things that these things do. Here's some problems with deficiencies. Cholesterol sulfate, it catalyzes the synthesis of something called filaggrin. And if filaggrin gives you makes your skin impermeable to microbes and to water. So, and then if you have too little of it, you're going to get these conditions. This thing, eczema, of course, and asthma, which are very common in today's world, especially among the children. And also this thing called eosinophilic esophagitis, which you don't want to get. This thing makes it very difficult to swallow, and that's a problem with inflammation in your throat. These are both due to cholesterol sulfate deficiency. Impaired cholesterol transport. Now, this is my next topic. Very interesting topic here, because the researchers don't understand how cholesterol gets from the places where it's synthesized inside the cell, which is called the rough endoplasmic reticulum, to the cell membrane in order to get out to the blood to be delivered to other cells. Because cholesterol is insoluble in water, there's a problem, and they haven't seen any kind of transport mechanism that would get around that problem. So I think the answer is to sulfate it. Once you add the sulfate, then it can just swim across the cytoplasm, which is water-based, and get to the membrane without a problem. So here's just a little picture to illustrate this. This is the cholesterol being made here in this rough ER. This is the little sulfate symbol that I use. So it's attached to the sulfate. It can just go right across the cytoplasm to the membrane, and then right across the blood into the HDL particle, which is the particle that gathers up the cholesterol from the cells in the skin that provide a great deal of cholesterol to these HDL particles. And it turns out cells in the skin are major suppliers, this is known, of cholesterol. The liver sends out these empty containers of HDL, and they go and they gather up the cholesterol in the skin. And furthermore, low cholesterol content in HDL is the strongest lipid predictor of heart disease. It's stronger than high LDL. And not just low HDL, but low cholesterol in HDL. So when a cell is deprived of cholesterol, it faces two tough choices. These caveoli are these regions in the cell that are very, very important for things like getting glucose in. And you're going to have insulin resistance if you don't have enough of those. And these things are loaded with cholesterol. So if you've got too little cholesterol in your membrane, just get rid of some of those. You won't be able to bring in as much sugar, and you'll have insulin resistance. The other thing to do is to just say, well, we'll just let the ions leak. We'll deplete the cholesterol in the rest of the cell. Potassium will leak out. Sodium will leak in. And then we'll have to pump them back out again and waste a lot of energy. So either way, you're going to have insulin resistance, or you're going to have excess oxidation damage due to the additional energy requirements. So here's a picture. I like this little picture here of the cell membrane with a lot of potassium inside with a big K and then a little bit outside. Sodium is more concentrated on the outside. The cell is always pumping these ions to the other side of the fence. And once the membrane starts leaking, then the sun wastes a lot of energy pumping them back. And eventually it gives up, and it says, well, look, we'll just forget about potassium. We'll switch to calcium. And that's when you get calcified plaque and calcified valves. It's not good. So this is a consequence of insufficient cholesterol in the membranes. And so eventually you get into trouble. So the absence of the sulfate causes the cholesterol to accumulate inside the cells that are producing it, or the cells like the macrophages that are storing it, and they can get overloaded with cholesterol inside their cell. The ER actually gets in trouble if it's got too much cholesterol, because it can't get rid of it because there's no sulfate, and then it can't fold proteins. And that's a major problem for the cell. It can end up in cell death, because once it's got this unfolded protein response, the cell can't really manage its life anymore, and it has to just give up. Okay, next topic, autism. So as I said, these are two of the articles I've written on autism, both of them clearly proposing cholesterol sulfate deficiency as a problem in autism. And this one links it to epigenetics. So these are both 2012. They've just recently been published. This is just some of the ideas from those papers. Very interesting to me that cholesterol sulfate accumulates in large amounts in the placental villi in the last trimester of pregnancy, and the placental villi are delivering then that cholesterol sulfate to the fetus. And I think that's how the fetus gets its cholesterol and its sulfate from the mother. Very, very important to the fetus. And it's essential for sterile transport and extracellular matrix protein health that we mentioned before. It detoxifies these things that the kids are getting in their shots, aluminum and mercury, so they don't have enough sulfate. They're not going to be able to get rid of the aluminum and mercury in the shots, and that's going to cause problems. It's also severely deficient in autistic children. They have only 1/3 of the normal level of free sulfate. It's been measured, and these autistic kids are deficient in sulfate. So those are some other papers. Another thing interesting is that autism is associated with several health issues. All of these are related. I mentioned these before, the eczema and the asthma. Infection because cholesterol sulfate produces a filaggrin, which gives you the barrier that keeps the microbes out. So the microbes are getting in because there's not enough cholesterol sulfate in the skin or in the gut. And these microbes are then causing these infections. And of course, digestive problems are well known with autistic children to those who are familiar with that space. And they're also due to sulfate deficiency. There's papers on colitis and Crohn's disease showing that sulfate deficiency in the gut is associated with those diseases. And so I mentioned this already, the filaggrin, and this too. So I sort of said all that. Yeah, good. So those are just some of the ideas that are talked about in those papers. All right, sunscreens. Are sunscreens doing more harm than good? This is a book I recommend, written by Elizabeth Plourde. I've read it. It's very impressive. It's got 300 references at the end, an extremely well documented intellectual book talking about all the different problems that she sees with sunscreen in the environment, causing harm not just to us, but also to the fish and the coral. They don't prevent cancers, they promote them. I gave a hint of that before. When they're absorbed through the skin, they disrupt our body's balanced hormone system. And they're also causing troubles in the hormones of fish, ending up with some very strange fish that are bisexual and things like that. And the coral, I think, are really getting clobbered by the people who are snorkeling in the coral and having all this sunscreen getting into the water and causing damage to the coral. Sunscreens directly interfere with vitamin D3 synthesis, and she talks about that in her book. And if it's 8, it's already 92.5%. Once you've got to 15, it's 99%, and we've got like 60. So we clearly are not going to be able to produce any vitamin D if we've got sunscreen. And she estimated the cost due to the excess cancer due to vitamin D deficiency in that range, compared to the excess UV exposure that we're preventing. So she's arguing that it's not cost effective to be using these sunscreens. And of course, I think the much more serious problem is the loss of cholesterol sulfate synthesis. Here's a paper on vitamin D in breast cancer, and lower serum vitamin D levels are associated with larger tumor size with a very strong p-value. And patients who have their level less than 30 have significantly increased risk of relapse of their cancer after 3 years. This just shows that it's related to cancer. Here's another story about skin cancer in the US. A quote from this paper: there's an epidemic of this non-melanoma. This is the less dangerous version, non-melanoma skin cancer in the United States, as illustrated by comparison with the previously published estimates, 4.2% yearly average increase in the Medicare population over this period when sunscreen usage was increasing. So this is an interesting point here. So the squamous cells in the skin mature into keratinocytes, and they produce cholesterol sulfate up here at the surface of the skin. And as I've said, it forms these cross-linked envelopes which protect you from microbial invasion and water loss. When you add vitamin A to the skin in sunscreen, which almost all the sunscreens contain vitamin A, then the idea is that it's supposed to be antioxidant and slow skin aging, which is a very appealing message that they pitch. But the fact is, when you put vitamin A on the skin, the cholesterol sulfate synthesis becomes impaired. So here's a paper, and there's a plot exposing the skin cells to vitamin A. This is cholesterol sulfate here on this axis, and this is the amount of vitamin A. So as the vitamin A level goes up, the cholesterol sulfate level goes down quite sharply. This is, if you just search the web on vitamin A sunscreen, you get a bunch of hits, all warning about skin cancer. And we'll just take a look at this one right here in this next slide. Vitamin A accelerates skin cancer. So this is just some examples of some charts on vitamin A exposure, low UV here, high UV here. And this is the weeks until the significant tumor development occurs. So longer is good, and so it's taking less time to see the cancer as you add more. This is 0.1, 0.5. As you add more vitamin A to the skin, you shrink the amount of time before the tumor appears from the exposure to the UV. So it's making that situation worse. So what do you live in the northern climate? My last section. Obviously exploit summer sun. Spend as much time outside in the summer as you can. You can accumulate your sulfate and your cholesterol in all your cell membranes and keep them healthy through the winter on reserve. Throw away the sunscreen. I don't use any. And your body can stock up on cholesterol sulfate for the winter months. These are the foods that are rich in cholesterol and sulfur, and I recommend eating as many of these as you can. This represents a whole class here, the cabbage, just like broccoli and cauliflower. Onions and garlic are very good. Liver, seafood, cheese, crab, beer is a nice one. So it's not a bad diet, really, I think. I eat a lot of these foods, and I would encourage you to do the same. So wintertime, you really should justify spending the money and go to the tropics for a week. What? What was that? Oh, this right here? Yeah, that's like dried apricots because they're treated with sulfur for the drying process, and those dried fruits then can work for that reason. Tropical place in the winter. I think if you live in Canada, you should use a sun lamp. It's another way to get the light. And then this is the only supplement that I use. I use it in the bath. Epsom salts. I really recommend it. It's cheap. It's easy. You throw it into the bath water. You get the nice hot bath, and you just relax in the water for 20 minutes on a regular basis. And of course, this is a sulfur hot springs, which is if you've got access to those, that's even better. Okay, summary. Sun exposure to the skin is about much more than vitamin D. The skin depends upon sunlight to catalyze cholesterol sulfate synthesis, and cholesterol sulfate play widespread roles in the tissues and the bloodstream. The current autism epidemic may be caused in part by aggressive sun protection. And sunscreens are damaging not just because they prevent vitamin D, but because they deplete cholesterol sulfate and actively promote skin cancer. And that's it. Thank you.
Thank you. Well, I'll tell you what, we got to take a break, but let's take a couple questions anyway. I mean, this is too good to pass. Mr. Larson.
What do you do for sun protection if you burn in the sun?
You leave the sun when you're going to burn, basically. That's what I do. You either put some clothes on or get out of the sun, And I think by wearing the sunscreen, you can be deceived into thinking that you're safe and staying out longer and actually getting more UV damage. So by not having the sunscreen, you're self-regulating, and you'll know when you're in trouble and you'll quit.
Will the zinc oxide protection be better?
I wouldn't recommend it, no. Oh, magnesium sulfate. Magnesium sulfate. And actually, the magnesium is probably good for you, too. It's just magnesium sulfate. Yeah?
Question to the answer of how do you protect yourself from going to the sun. 5 years ago, a study was done in Australia where they gave sunscreen to 21 patients, and 21 patients they gave them aspirin prior to going out of the sun for 21 days. And they did a chromosomal damage measurement on the skin, and they found almost no damage was done on the aspirin group during the day keeps the sun away. No, it was a regular 325 milligrams.
Okay, one more question? Yes, ma'am.
I think so. I recommend taurine, chondroitin sulfate. You can get S-adenosyl, I don't know how to say that, methionine, SAM, and also the same thing, cysteine, done that same way. Yeah, taurine, I think, is a very important nutrient that people are not aware of. It's a sulfur-containing amino acid as well.
Is there sulfur in N-acetylcysteine?
Yes, they all have sulfur, methionine, cysteine, and taurine, but methionine and cysteine have to have this extra complication in order to get absorbed properly.
Okay, very good. Wonderful. Thank you, Stephanie. Okay, I'll tell you what. Well, that was, I hope you all, I'm sure you do appreciate it. That was really fun. But anyway, we'll now take our usual break, and we'll reconvene at 10 after, or thereabouts. So enjoy, and I think there's some nice watermelon and things over there for people, so talk to you in a bit.